Okay. Good morning, everyone. Myself, VLD Prasad Reddy, working as Assistant Professor in the Department of Civil Engineering Department. Today, I am here to start the course Engineering Mechanics. Okay, in a series of video lectures, we are going to complete the entire course Engineering Mechanics. Here, the entire course is having 5 different modules. In module 1, the topics are like Introduction to Engineering Mechanics and System of Forces. And in module 2, we are going to cover Equilibrium of Forces. And in module 3, we are going to cover centroid, center of gravity, moment of inertia. Again, in moment of inertia, there are 2 topics like mass moment of inertia and area moment of inertia. And in module 5, we are going to cover curvilinear and rectilinear motion of a particle. And in unit 5, module 5, we are going to cover rigid body motions. Okay, this is the entire syllabi which we are going to cover in a series of video lectures. First of all, let me introduce what is engineering mechanics, because in module 1, the main contents are Introduction to Engineering Mechanics and System of Forces. Then, first of all, I want to start what is engineering mechanics, because everyone should know first of all what is engineering mechanics, and slowly we can enter into the course. Then here, what is engineering mechanics? Okay. First one is first of all, everyone should know what is engineering mechanics. Here, mechanics is a branch of science or a branch of physics which will describe the response of a body under the action of loads. Nothing but let us consider any body when it is under the action of several loads, then how the body is going to respond. Here the response may be of 2 types. The first one is external response and the second one is internal response. Okay, let us take a body. Suppose if this body is under the action of several forces, then how the body is going to respond. That is what exactly engineering mechanics explains. Nothing but during the application of these forces, suppose if the body tends to displace, over a distance of some x meters, nothing but this is an external response, nothing but which can be observed from the outside. Just by looking here, I can say the body is displaced over a distance of x meters. And as well as due to the application of these loads, how the internal stresses or how the strains are produced within the body, they are called as internal responses. Here in engineering mechanics, only we are confining to external responses, nothing but the responses which are observed from the outside. Then nothing like how the member is displaced and with what velocity the body is traveled and what is the acceleration of the body, like that all these parameters are going to cover in engineering mechanics. Clear? Here mechanics is a branch of science or a branch of physics which will describe the response of a body, under the action of external loads. Okay, clear? Then what is engineering mechanics? The term itself indicates engineering mechanics is nothing but here we are going to add some engineering principles to get the solution of so many mechanical problems. Nothing but let us consider if you want to design different components of a bridge, or if you want to design different components of a building, or if you want to design different parts of a machine, where first of all we should know what are the various loads that are likely to act, and because of these loads, how the body is going to behave, means how the stresses are produced in the body, or whether it is moving with any velocity or not. Like that, all these parameters are going to study in engineering mechanics. But here we are going to use few engineering principles to assess or to give the solution for different mechanical or different civil engineering problems. Not only civil and mechanical engineering, but some other branches also, they might be using engineering mechanics. Clear? Then, okay, that is all about engineering mechanics. Next, that is all about engineering mechanics. Then what exactly we are going to study in engineering mechanics? Then basically everyone should know what are the different cases that we are going to evaluate in engineering mechanics. Nothing but in engineering mechanics, again we are going to read two different bodies. We are going to read two different bodies. Engineering mechanics. Here we are going to read two different bodies. The first one is when the body in static condition, and second one is when the body is in dynamic, or when the body is in dynamic condition or in motion. Clear? In engineering mechanics, we are going to discuss, or we are going to solve two different types of problems. Either the problems are belongs to static condition or in dynamic condition. Here, what is a static condition? Then static condition is nothing but when the body is in rest. Even though there is an action of force, but still the body is in rest condition, then the body is said to be under static condition. As of now, there is no velocity, there is no acceleration, and there is no displacement in the body. But after the application of load, it may be entered into the dynamic state, but as of now it is in static condition. Therefore, in statics, we are going to discuss the bodies which are in rest condition. Then how these bodies are going to respond under the action of external loads. That is what exactly we are going to discuss in statics. And next one is dynamics. In dynamics, again we are going to consider the bodies, but they are in motion, they are in moving condition. Here in this particular topic, we are going to consider only the bodies which are in motion. Then how the bodies are responds, when they are subjected to external loads. That is the exact difference between static and dynamic conditions. Clear? Again, dynamics are further classified into kinetics and kinematics. Okay. Now there are three different categories. First one is statics. In statics, there is no further subclassification, but whereas in dynamics, the same bodies are further subclassified into kinetics as well as kinematics. Here, this entire classification is depending on the state of the body. Nothing but whether the body is in rest condition, whether the body is in motion. Okay, depending on the state of the body, we are going to use the appropriate principles, because the response of the body when it is in different states is always different. Okay. First, let me take some example to explain the entire classification. Suppose let us take a member. Okay, let us take a member which is supported at the either ends. Okay, as of now, this body or this object is in rest condition, because the body is not having any velocity, any acceleration. Therefore, the body is said to be in static condition. Suppose if this body is subjected to some amount of external force, some F. Suppose if this body is subjected to some amount of external force, F. As a result of this external force, how the body tends to behave, nothing but how the body is going to respond. Here the response may be external or may be internal, but in engineering mechanics only we are going to consider the external responses. We are not going to consider the internal responses of the bodies. Suppose if this body will be, as a result of this load, suppose if this body is going to deflect in downward direction, is going to move in downward direction, therefore this movement or this displacement is known as external response. Suppose if the same body tends to oscillate, suppose if the same body tends to oscillate in upward and downward directions with some velocity, which is also known as an external response, because all these responses can be observed from the outside. We need not to cut the member, and we need not to look into it and how the member is going to deform, or how the changes are taken place within the body. Okay, we don't cover all those topics in engineering mechanics. Only we are going to capture, or we are going to cover the external responses, nothing but deformations, velocities, and accelerations. Okay, these we are going to cover all these parameters in engineering mechanics. Okay, this is the first case. Here the body is in rest condition. Suppose, what is kinetics and what is kinematics? Again, let me take some example. Here, let me take some example to make it clear to you. In kinematics, only we are going to consider the response of a body. Only we are going to consider the response of a body when it is in motion. But we did not consider the forces which are responsible to that motion. Okay, let us consider when a car is moving on a road. Let us consider when a car is moving on a road with some velocity. Therefore, what will be the distance? Then what will be the distance covered by the car within a time of t seconds? Okay, here we did not consider the forces which are responsible for this task to cover this distance. Nowhere we have defined the forces or the parameters which are responsible for this task. This is what we call as kinematics. Okay, clear? In kinematics, only we are going to consider the response of a body when it is in motion. But at the same time, we did not, or we are not going to consider the forces which are responsible for that motion. Clear? Whereas in kinematics, we are going to consider the forces also, because here, suppose when the same car is traveling on the road, it may be, okay, the velocity of the car may be affected by wind, as well as the velocity of car is affected by the friction between wheels of the vehicle and road, and also the weight or the self weight of the truck, whatever it is. Okay, these are all the parameters which are influencing the velocity of the truck. But here in kinematics, we did not consider all these parameters which are governing or which are responsible for the motion, nothing but velocity of the truck. But in kinetics, we are going to consider all these parameters. Means we are capturing the response of the body. At the same time, we are considering the parameters or the what it is, factors which are affecting the velocity of the truck, nothing but its weight and the effect caused by the wind and the friction between the road surface and the truck, whatever it is. Okay, these are all considered in kinetics only. In kinematics, there is no discussion about the forces. Only we are going to consider the responses only. Clear? This is entirely about the classification of engineering mechanics. Clear? And next, what are the different types of bodies? Okay, this is Okay, this entire classification is based on the state at which the bodies are present, whether it is in static condition or rest condition, when they are in motion. Then depending on the state of their presence, this is how the mechanics is further subclassified. But if you consider the type of bodies, basically there are two different kinds of bodies are there. The first one is rigid bodies, and second one is deformable bodies. Okay, what is a rigid body and what is a deformable body? First of all, everyone should know about what is a rigid and what is a deformable body, because while solving the problems in engineering mechanics, we have to consider what type of body it is. Then what are the different types of loads, or what are the different types of forces which are acting over that body. If you know all these data, if you know all these details, then only we can able to solve the problems. Therefore, everyone should know what is a rigid body and what is a deformable body. Here, rigid body is nothing but when the body is subjected to external loads, but still there is no change in its position, in its shape, and in its size, everything. Nothing but let us take a body. If it is subjected to a system of forces, a set of forces, then even after the application of forces also, still the body is in same position, is in same size without having any deviations. Then the body is said to be a rigid body. And second one is a deformed body. Here deformed body is nothing but after the application of loads, if the body tends to deform, means nothing but if it changes the shape and if it changes the size, whatever it is. Let me take another example. Suppose let us take another body. But here after the application of these forces, suppose if the body tends to change its shape, okay, this is called as a deformable body, and this is called as a rigid body. Okay, did you understand the difference? Rigid body is nothing but after the application of forces also, the body should be in the same condition without having any changes. There should not be any physical change, nothing but change in its size, change in its volume. No such deviations are there in case of rigid body, whereas in case of a deformable body, the body tends to deform, nothing but the body tends to change its shape and size after the application of forces. Those type of bodies are called as deformable bodies. But here no body present on the earth is exactly rigid, because you take any example, you take a bridge, you take a car, you take a building, any machine component, whatever it is, ultimately at some point of time, all these elements, all these bodies tends to change their shape after the application of load. Okay, if you take a bridge, okay, whenever the vehicles are moving over the bridge, ultimately at some point of time the bridge tends to deflect or deform from its initial position. Here deformation is nothing but the body has to take some certain deviation from its initial condition. Okay, clear? Therefore, all the bodies or all the elements which are present on the earth are ultimately deformable. But at each and every point of time, you may not get the deformations, but at some point of time, whenever there is a sufficient amount of load, then ultimately each and every body present on the earth is going to deform. But then what is the use of rigid bodies? because as I said, there is no presence of perfect rigid body on the earth. Then why should we use this particular name? Because suppose when we are solving so many problems, in all the cases we don't have a chance to consider the body as a flexible one, as a deformable one, because if you consider all the deformations during the application of load, then our analysis will become quite complex. Okay, let me take one more example. uh, almost all the bodies or almost all the elements present on the earth are deformable at some point of time. But why should we use the term rigid? Because when we are analyzing any body or any engineering component, any mechanical machine tools or any bridges, any structural components, whatever it is, then at some time, at some point of times, we have to consider the body is a rigid body. Otherwise, our problems or solutions will become quite complex. Okay, in order to avoid that complexity, we are assuming that those bodies are behaving as a rigid bodies for some time, only for some time. Suppose, okay, let us take a beam. I think all of you know. I think most of you don't know about the beams. Okay, let me take one more example. Okay, let me take one more example. Okay, let us take a block. Okay, let us take a block which is also a body. Suppose if this block is subjected to two equal and opposite forces. Suppose if this block is subjected to two equal and opposite forces, here the forces are acting towards the body. Here the forces are acting towards the body. Suppose if you consider this body as a rigid one. Suppose if you consider the body is a rigid one. Therefore, the total deformation in the body, therefore the total deformation in the body will not be found out, because after the application of body, after the application of force, if the body is rigid, it does not undergone any changes, then the body is still in the same condition. There should not be any deformation like that. Then in this case, the body is considered as a deformable body. But when we are analyzing a beam, and the beam is subjected to some amount of load. Let us take a member which is held rigidly at this point, and the member is subjected to some amount of force here. The member is subjected to some amount of force at this location. Then if you want to calculate the amount of movement caused by this force at this support, if you want to calculate the amount of movement caused by this force at this support, here movement is nothing but force into distance. Okay, that is the formula we are using to calculate the movement caused by a force at some location. Okay, suppose if you want to use this formula, F into D, then let us assume the length of the member is L. Therefore, this is F. Therefore, the moment caused by this force at this support is F into D, which is quite easy, because here we did not consider the deformations or changes that are taken place within the body. Suppose if you consider all those deformations, then normally what will happen, whenever the body or whenever this member is subjected to some amount of downward force, then this is how the member tends to deflate. Then now the force is acting somewhere here, means it may be still vertical, or it may be having any deviation or any inclination, whatever it is. If you want to apply the same formula to calculate the moment at this location, which is very difficult, because after taking a deviation or deformation, now the calculation of length between the support and the force, which is very complex here, uh, which will be same, f will be same, but the distance between the force and the support is different, and the calculation of this distance is also much more complex. Suppose let it be f into some di. Let the distance between the force and the support after the deformation, let it be di. Then the expression for moment in this case is f into di. Okay, in the previous case, when we consider the beam as a rigid one, the formula is f into d, and where d is directly taken as length of the member, and f is nothing but the force which is acting at the extreme right side end of the member, where m is very easy, m is equal to f into d. Whereas when we consider the body as a deformable one, then calculation of distance between the support and the force where exactly it is acting, which is very difficult. Okay, but if you consider the values, suppose if it is 200 kilonewton meter, which is about 199.9 kilonewton meter, whatever it is, there is no much difference, even if you consider all the changes that are taken place in the body as a result of this force. But the problem will be quite lengthy, the analysis will be quite lengthy. Then in order to simplify the solution, here we are assuming that the body is a rigid body, but actually it is not a rigid one, which is a flexible, which is a deformable one. At some point of time, the body is displacing or deforming. Clear? This is the exact difference between a rigid and a deformable body. Clear? Okay. Okay. This is exactly about the introduction of engineering mechanics. What is engineering mechanics, and what are the various types of problems we are going to solve in engineering mechanics, like statics, dynamics. Again, in dynamics there are two different kinds, kinetics and kinematics. Okay, we are going to solve different problems in these categories, in these types of issues. And next, deformable bodies, rigid body, and what are the differences between these two. But in engineering mechanics, most of the cases, almost in all the cases, the bodies are treated as a rigid body, because here in engineering mechanics only we are going to evaluate, we are going to study the external response. Okay, external response is nothing but displacements, velocities, and accelerations. Okay, in order to study these external responses, the body has to be considered as a rigid one, because if you consider the body is a deformable one, then the analysis will become quite complex. But there are some other courses like strength of materials and mechanics of solids, and designing subjects are there. In those subjects, exactly we are going to consider the deformations that are taken place in the body in the analysis where it is needed. But in engineering mechanics, we don't need the deformations within the body as a result of external forces. That is why in engineering mechanics we are considering almost all the bodies as a rigid one. Clear? We are not going to consider the deformations. Then this is all about basic classification of engineering mechanics, what is engineering mechanics, and what is rigid and deformable bodies. Clear? Okay. And next one is, okay, in introduction we have to cover few other topics like what is force, which is very very essential in engineering mechanics. What is force? Here force is nothing but the parameter which exactly represents the interaction between bodies. Okay, force is nothing but the parameter which is exactly represents the interaction between the bodies. Okay, let me explain in another manner. Let us take two bodies. Okay, let us take two spherical balls, uh, and they're keeping on the ground, and they're kept on the ground by facing their surfaces together. Okay, this is how the spherical balls are placed on the ground. Then here the interaction between these two spherical balls is nothing but force. Then let me explain clearly. Suppose when these two balls are meeting each other, this ball is going to apply some amount of force, as well as the second spherical ball is also going to apply the same amount of force in the opposite direction. If these two forces are equal and opposite, then still then they will be under the same condition. And let us take one more example. Let us consider a building which is having different components like beams, columns, slabs, footings. Here, let me take two different components like slab and beam. Here, the interaction between slab and beam will be like, here the beam is used to support the slab. Therefore, the weight of the slab and the external loads which are acting on the slab are going to supported by the beam. Therefore, as a result of these external forces, the beam tends to deflect or deviate in the downward direction. Here, this is how the beam and slab is interacting. Clear? Here we are standing on the slab. Therefore, R weight plus self weight or own weight of slab is directly supported by the beams because they are interacting in that manner. Then whenever they are interacting, the weight of the slab as well as the weight of the persons who are standing over that slab are trying to push the beam in downward direction. This is how the force will act. Force will explains the interaction between any two objects or any two particles, and also it will try to create the motion, or it will try to change the motion of one body if possible. Clear? Suppose in all the cases we might not see the beams are deflecting in downward direction because the reason is the self weight of slab as well as the self weight of the weight of external loads are not able to displace the not able to displace or not able to deform the beam in downward direction, but still they are trying continuously. Clear? They may or may not displace, but always they are trying to change the motion of the beam. Here the spheres are always trying to change their motion. One sphere is trying to change the motion of another sphere. Okay, that is a continuous process, but whether there is any change or not, that is depending on the force and its magnitude. Clear? That is what exactly a force. And next one is how to characterize a force. Characterization of a force, or how to define a force. Basically, force is a vector quantity. Almost all physical entities or physical parameters present on the earth, either they are scalar quantities or vector quantities. Then what is the difference between a scalar and vector? Nothing but the parameters which are having magnitude, and they're having location, and they're having direction. Let us take force. Okay, let us take force. Okay, let us take the same example here. The force here, the force from the sphere 1 is acting over sphere 2 in this direction with some magnitude. Magnitude is nothing but quantity. Suppose 200 newtons. Suppose 200 newtons of force is acting from the sphere 1 to sphere 2 along this direction, along the horizontal direction. Then here the force is having both magnitude and it is also having the point of application. Here this is the point where exactly the two forces are meeting. This is nothing but point of application where the forces are exactly acting and the direction in which the force is acting. Here the force is having a magnitude of 200 newtons and it is meeting the sphere B at this point and in horizontal direction. Therefore, generally force is a vector quantity or vector parameter which is having magnitude, which is having point of location, and the third one is the location in which it is acting, point of contact or point of acting, and third one is the direction in which it is acting. Clear? Then usually force is having, or force is characterized by magnitude, and second one is location of action, means where exactly it is acting, location of action, and third one is direction. Okay, if any parameter is having all these three characters, then that parameter is considered as a vector. Here force is a vector parameter. Clear? This is what about force. Then how to represent force? Usually when we are discussing about the representation of force, usually forces are represented in either newtons or in kilonewtons. Usually forces are represented either in newtons and kilonewtons. Okay. In the next class, I will continue the remaining topics. Thank you.